This is a quadratic inequality because you have an inequality symbol, not an equal sign. Now, that may be greater than and equal to, or greater than, or less than or equal to. Only difference the equal to will be if you have brackets instead of parentheses. Always get 0 on the right of your inequality symbol. Okay? Now, this A is positive. All right, and if I had fractions, I would clear my fractions as well. Now, the way you're going to find your critical numbers, you're going to take ax squared plus bx plus c, which is you've already made it in standard form, and you're going to set it equal to 0. And you're going to find x equals some number, and then x equals some other number. Okay? We'll call one of them z and the other one w. Okay? So those are your critical numbers, and they're critical numbers. I'll tell you why they're called critical numbers in a minute. And then what you're going to do, you're going to draw a number line, and you're going to place your numbers on the number line. Okay? Now, the reason these are called, your z and w are called critical numbers, because as you pass across through z, whatever number you use, x value, to the left of z, and you plug it in here, it's either going to be positive or negative. This whole entire region will either be positive or negative. Same thing, if you plug in a number in between your two critical numbers, you plug it back into your standard form, it's going to give you either a positive number or a negative number. And the same thing for this upper region, w. Whatever number you plug in this region, just pull a number out, stick it in here, and it's either going to give you a positive or negative number. Now, the reason z and w are called critical numbers, as you pass through, across, the signs will change. For example, if this had been a plus, then over here would be a minus. If the region on the left had given you positive numbers, when you cross through your critical number, it'd be negative. They're going to alternate. Now, that's not true for higher order equations. It may not always be true, but for the ones that we have that are quadratic in nature, it will be true. This will make more sense when we do an actual example. All right, and then I've already kind of got into this. 4, test each interval. That's where you pulled some number out of this interval over here, and you figured out if it gave you a positive number or a negative number. Always test 2 intervals to make sure you haven't messed up. Step 5, determine if you want positive or negative intervals. So what you do, in our case, we've got ax squared plus bx plus c is greater than 0. Determine if you want positive or negative intervals by looking at standard form. I'm looking for numbers that are greater than 0, so I'm looking for positive areas. If you had ax squared plus bx plus c less than or equal to, it doesn't matter. What kind of numbers am I looking for? I'm looking for x's that make this negative. And then we'll write our solution in interval notation, and I will show you how to do that with our examples.